to Unit 4, Determinants of Air Pollution and Health Impacts. By the end of this unit, you will describe the determinants of air pollution, including population growth, urbanization, increased energy consumption, climate change, as well as meteorological conditions. The world's population is projected to increase by 2 billion individuals in the next 30 years, reaching its peak around the end of this century with nearly 11 billion people. Sub-Saharan African countries will account for most of the growth in the world's population over the coming decades, while several other regions will begin to experience decreasing population numbers. More people living on our planet will mean that more resources are needed to enable populations to thrive. We have learned that this often leads to anthropogenic-induced emission of pollutants in the atmosphere, for example, for energy production and consumption. The increasing urbanization of the world's population is another important factor determining air pollution health impacts. Globally, the majority of the world's population, 55% in 2018, lives in urban areas as opposed to rural areas, and this is expected to increase to 68% by 2050. Increasing energy consumption is another determinant of air pollution. In the second half of the 20th century, energy consumption, mostly from fossil fuels, had grown to levels of an order of magnitude higher than during the middle of the 19th century. Globally, we continue to use ever-increasing amounts of natural resources to support our economic activity, and the generation of waste is mounting. Also globally, the material footprint, the number of raw materials extracted to meet final consumption demands, showed an increase of 113% from 1990 to 2017. Economic and social progress over the last century has also been accompanied by environmental degradation that is endangering the very systems on which our future development, indeed our survival, depends. The more we consume in an indiscriminate way, the more we contribute to environmental degradation, including air pollution. Air pollution and climate change are also interlinked. Sources of climate change and air pollution often overlap, with 2/3 of outdoor air pollution emissions generated by fossil fuel combustion. Some air pollutants, such as ozone, can exert direct and indirect effects on the climate due to their warming potential as short-lived climate pollutants. They also negatively affect ecosystems. For example, ozone impairs the ability of plants to absorb carbon dioxide from the atmosphere. Some of the consequences of global warming, such as deforestation and increased frequencies of wildfires, also contribute to the release of health-threatening air pollutants to the atmosphere, such as particulate matter. This is why interventions to address air pollution also support climate change mitigation. Meteorological conditions can influence the dispersion of air pollutants in the atmosphere. These include temperature, relative humidity, precipitation, wind velocity and pressure, solar radiation, and visibility. Topography also plays a significant role in how pollutants are dispersed in the atmosphere. For example, certain topological characteristics, such as a valley or a mountain, may facilitate the formation of an inversion temperature layer that acts as a barrier for the dispersion of pollutants. Normally, the temperature of the air decreases as altitude increases. During an inversion, this normal temperature profile is inverted and warmer air is held above cooler air. When this happens, emitted pollutants will be trapped and kept afloat by a specific air parcel. As pollutants are increasingly emitted, the outdoor concentration will rise considerably over time. The combination of lingering air and the abundance of particles and other pollutants in the air produces urban dust domes and heat island effects. You have now completed Unit 4. Download the reading materials for more details on this topic. In the next unit, we will look at WHO milestones on air quality and health.